So thank you everyone for joining today. We'll go ahead and get started as more people start to trickle in. So this workshop is part of the Next Top Blockchain Startup, a global online hackathon startup competition and accelerator program. The event is also hosted by Ben, the Blockchain Education Network, the largest and longest running network of students, alumni, professors, teachers, professionals, and community leaders excited about blockchain across the world. Please welcome Ricardo from the Polkadot team.
Thanks, Ben. Okay, so let me share my screen. Now, as Ben said, my name is Ricardo Rius. I'm a solutions engineer at Parachain Technologies. We are developing the first version of Polkadot using Substrate, something I will be talking about. Yeah, that's basically me. So what we are gonna be talking about in high level, just to make everyone understand what's Substrate, what's Polkadot. So we will mention some topics or programming language like Rust, WASM, which is WebAssembly. We're gonna talk about blockchain upgrades and some part of how we can do inter-chain communication. Okay, so one of the things that we have seen so far is that there's no way that one chain, one size really fits all. Like there's no just one solution out there, like one main chain that can help every existing use case out there. So for every different type of requirements, we also require a different solution. So this puts us in a different position. We need to stop thinking about chain maximalism, and we can start thinking about a future with multiple blockchains. But in order to have this, we need blockchains to work for specific purposes. And it's not only that, they also need to work together in an efficient and secure way. And very importantly, something we have seen right now on some blockchains are struggling, it's scaling. So this is also quite important right now. There's also a huge need to do upgrades. The main reason is because we need to fix important vulnerabilities, change some core protocol rules, add new functionalities, or even repair some chain state. One of the trickiest things right now with existing blockchains is that in order to do an upgrade, add new functionalities to a blockchain, is you need to hard fork. And these hard forks require a lot of coordination. This means that if not all the nodes upgrade at the same time or in a certain period of time, there's a huge chance that some nodes will go and continue using like the old version, and they will defer, and the security of the network will be degraded. So this is quite important. Also, another important thing is, now that we decided that upgrades are needed, how can we coordinate these upgrades? So many times we have some offline, off-chain forums, and while these forums are good, these forums are also centralized, and even the conversation mainly happens between just a few developers and a few people, and many times like there's really no this sense of everyone voting, and kind of you can, even if you are a big stakeholder on the chain, you can still get ignored quite easy. So that's why it's kind of really interesting to start exploring, and really it has been proved that on-chain governance has played really well, because it helps you also fixing some issues. Some things you can also do, like this is just part of Substrate, I will mention more, but it's you have different type of governance. You can have like just super powerful user like sudo, or you can have like more decentralized using democracy, or create your own logic. Now, one of the biggest issues right now that all the ecosystem it's facing is that we are getting into a really fragmented landscape. Many of these blockchains cannot talk one with each other, and then we started creating some data silos to one blockchain. Yeah, works pretty well from one use case, and then another one kind of works a little bit for another use case, but then there's no way to interact without a centralized service. And again, this just defeats the full purpose of blockchain. So yeah, there's also like a huge problem that many use cases right now remain just as non-real world use cases. Like really, we see that in order to not saturate the chain, then there's some use cases, some gaming use cases, they put some limits in there in order to like be able to use generic blockchains. And yeah, also in order to really create real world use cases, we also need to start creating more specific purpose blockchains. So this will really handle, for example, something for supply chain, something for I don't know, maybe Internet of Things, or yeah, there are like really different use cases, but or finance. All these needs to be embedded on the main core logic of the blockchain. So what are one of the existing problems? Yeah, one of the main problems is if we have only a single chain, then there's a limit on all the number of transactions. So this limit generates usually a bottleneck because yeah, everyone wants to put their own transaction in there, and then yeah, this just stresses a lot the blockchain. And this bottleneck also generates another issue here. It automatically increases the transaction fees, and this just becomes unscalable in many times. We have seen, yeah, in many examples so far. So how can we handle this new multi-chain blockchain ecosystem? Well, we can use Polkadot. With Polkadot, it's a network interface that allows us to ensure that all these new blockchains that we start creating, they can interact one with each other in a decentralized way. That's one of the important things. This is how we envision Polkadot in the, yeah, let's say medium term. There's gonna be a lot of communication between different terms of calling them a blockchain. We call them Parachain in Polkadot, and yeah, there's gonna be a huge ecosystem in there. So let me explain a little bit more. So what you saw here, it's a bunch of a lot of blockchains interacting one with each other. I'm explaining a bit more the other diagram. We can see here that we have something that is called a relay chain. Relay chain is it's the technical name that we use for Polkadot or Kusama or yeah, any other testnet. And the relay chain is just in charge of making the first, like giving the security to all the parachains. It's giving the security by giving the finalization. So here we can see that, for example, in this part, this is validators. All these things here are validators for the relay chain. These are just validating the Polkadot network. Then we have here what is like just a graphical representation of a parachain or a blockchain with specific purpose. And then collators. Collators are just validators or the authority nodes of the parachain. So this means that we will have a lot of parachains. Here we have like just an example with 3 parachains. Then we have another kind of parachain, but this is a bridge. So for example, this bridge will be connecting to Substrate or to Ethereum or Bitcoin, something like that. And I won't touch that much this part, but it's kind of a way of using your own blockchain, but just paying for the time that you use the blockchain instead of like just being connected all the time to the relay chain. So now, now that we know a little bit more what's Polkadot, how did Polkadot was created? Well, Polkadot started being created, just all the code about all the learnings that Parity had about creating different clients. We are talking about Parity Ethereum client, Parity Bitcoin, Zebra, which is a Zcash implementation. And yeah, a lot of things were so similar in many of these projects that we were able to create some modular framework. And this is basically Substrate, which is the icon on the right, was born from the main Polkadot code. So what is Substrate? Substrate, it's an open source, modular, and extensible framework. Why it's all, I mean, modular? It's because you can, in Substrate, we create a type of library where we create different modules, which are called palettes. And these palettes, you can basically like choose which ones you want to put in your blockchain and create your own palette. And the sum of all these palettes are the main logic of your own blockchain. So what are the things that we are fixing here with Substrate? I mean, with Substrate, we already talked about this, but all these things are quite easy to do with Substrate because the way how we operate Substrate, it's through using WebAssembly, and WebAssembly, it's just a virtual machine. I think I have another slide on that, that will execute the latest rules that we choose in there. So some things that Substrate already give us, it's giving us the database layer, networking layer, transaction queue, consensus, and this library called palettes. So now showing you a bit more about this, we have like just main runtime here. Runtime is the main logic, execution logic of your own blockchain. So we will have, for example, one of the palettes is governance. Another palette could be how you do the slashing, smart contracts, some kind of permissions. And all of these are just what creates all the logic in your blockchain. And one of the important things is that everything is compiled to WebAssembly, and this WebAssembly, it's just the virtual machine that executes all the runtime logic. Okay, so yeah, here's another example of what is the runtime. The runtime, as I said, it's a block execution logic. So we have frame, which frame is this number like this, all the palettes together, and you can select which ones go into the runtime. So we have contracts, balance, pseudo, or yeah, different type of palettes, and based on all these palettes and how one interacts with the other one, we can even create our own, and we can create all the new transition function of our blockchain. So one of the important things about Substrate is that there are no hard fork upgrades. For Substrate, everything goes just directly on one line. There's no way that it will, okay, in general, the main idea is that if you do a runtime upgrade, the runtime upgrade will just continue all the time with the same logic. There's no way that it will fork. And the main reason why it doesn't fork, it's because of this part that I have here. Like, we have all the runtime execution logic inside the virtual machine. So when we have the runtime, it's compiled to WebAssembly. This WebAssembly code or blob goes directly into one part of the blockchain. So every node that gets connected and gets in sync with the blockchain that it's the code, it's running whatever code, could be Polkadot, could be another blockchain or parachain that you are developing in order to connect to Polkadot. All of those are using Substrate, and all this, the way any client that is connected just to the main blockchain that you are syncing will have the latest code always. So after doing an upgrade, it could go, like, as I said, upgrade with governance, democracy, or using a pseudo module, with any way you want in there. Then the code will be placed in the blockchain, and then we will know that from one block, from block 0 to block, I don't know, let's say we did an upgrade on block 100. So from block 0 to block 100, we will have the old execution logic. And from block 100, we upgraded the WebAssembly code that is already on the blockchain. And all the clients that are connected to that blockchain will know that in order to validate all the previous blocks, they need to use the old version of the WebAssembly. And in order to use the new version of the WebAssembly, in order to continue validating the blockchain, they know that they need to use the new version of the WebAssembly block. And that's basically how we can make sure that in using Substrate, you don't fork your chain. And this is also really good because it will allow you to create some code, then you upload the proposal, and then everyone on the network validates the code that it's already there that you proposed. And if everyone gets the same WebAssembly code at the end, then you just vote in a decentralized way and approve the upgrade. This is one of the main difference with the existing protocols, where all the governance is off-chain, and then there's really no way to indicate that you want the upgrade or you don't really want it. And then yeah, there's just not really a lot of decentralized system in a supposed to be decentralized network. So yeah, that's one of the main advantages here. And yeah, this is something that will not happen with Substrate. And yeah, that's all for now. I don't know if there are any questions, something you want me to explain more or clarify.
Thanks, Ricardo. That was awesome. Does anyone have any questions? Feel free to drop them in the chat or raise your hand. If there are no questions, then any questions, anybody? One question is a Substrate backward compatible?
It is, right now, it's not really backward compatible. Yeah, that's something that it's work in progress, but it's moving so fast that right now hasn't been the main priority to make it backward compatible.
Okay. Then there's one other question. Could you please elaborate on the difference between the collaborator on Parachain and validators in relay chain?
Yeah, sure. Okay, so as we have in any blockchain, we need to validate all the blocks. So let's just right now disconnect from the parachain. Let's disconnect the parachain from the relay chain. So in order to do that, like, we just need collators. So collators are going to be these validators. They're going to be validating the blockchain, and the blockchain will work as normal. Now, when you need to connect the blockchain to Polkadot, then the important thing is that Polkadot will give the security to the whole network. It will finalize the blocks. So your collators will be producing the blocks. They will have the logic of your parachain, and they will produce the blocks. Then they will send a cryptographic proof of validity to the validator. So there's going to be some validator from the relay chain that will be assigned to a set of parachains. So this is why you can see here that in this case there are like just 3 validators assigned to a parachain, and there's also here other 3 validators. So these validators, their main function, the relay chain validators, it's to validate the relay chain, but they also need to validate the proof that the collators are sending to the validators. So when they, because also, okay, entering a little bit more in details, also relay chain will have the same WASM block that the parachain has, but this is just gonna live a little bit on these validators that are validating the parachain. So if we have the same WASM block on the relay chain and also on the parachain, then we can, whenever the collator sends a transaction and a new block is generated, then the validator can just check the proof that was sent to them using the same code that the parachain has. So the main role of one is the collator's main role is to execute the blockchain logic of the parachain. And then the main use or main task of a validator is to produce blocks on the relay chain, but also the ones that are assigned to a parachain, they need to validate the information that the collators are assigning, are sending. And through that, then after a few blocks, they finalize the parachain. So there's no way that a parachain can fork. Parachains cannot fork also because everything gets finalized by the relay chain. Hopefully that was clear enough.
Yeah, that sounds pretty good to me. And then one other question is, can we have 2 blockchains on the same network of nodes? Kind of a regular question.
2 blockchains. Yeah, well, okay, depending. So the way how I understand the question is like, I mean, one solution to that could be like what we call parathreads. Parathreads here we have like different parachains, but they cannot share the same collators. Each parachain has its own collator, but then since they are paying just for the time they are using from the relay chain, it's going to be cheaper execution. They need to pay less to Polkadot or to the relay chain, and they will share the same set of validators. So it's a parathread pool, and then they just pay for the use for the time they are using the relay chain. These are kind of use cases where really the blockchain doesn't need to be that active. There's not a lot of information moving on the blockchain or on the parachain, and it's just cheaper to keep it like in a hibernation state and then just pay from time to time when there are some transactions happening on the blockchain.
I have 2 questions.
Yeah.
So one is that the validators in the parachains, are they kind of random, or just like for a parachain, validators are fixed?
Okay.
That's the first question. And second question is that you said that the parathread pool contains parachain. Is that the parachains or just parathreads? Because I knew that parachains are kind of dedicated and parathreads are kind of on demand.
Yes, that's correct. Okay, yeah, let me explain. So yeah, for collators, this completely depends on the logic that you put on your own blockchain. They are not fixed. Like collators are just part of any existing blockchain right now, where you can use even you could use proof of work, or yeah, just easiest one right now for these use cases are proof of stake. But they are selected through an algorithm, and they are not fixed, and they also change based on whatever rules you implement, or if you use the rule that we already have on Substrate, then it depends on some reputation system. If they get disconnected so often, then the reputation goes down, and then a new collator can join and be on the set of validators or validating the parachain. So it's completely dynamic, all the collators. And yeah, for the parathread pool, yeah, you're right there. Like each parachain, so we call them parathreads, but in reality, you are building a full parachain, also with its own set of collators. But the main difference there is that they are not really actively sending information to the relay chain. They are just on demand whenever they need. So all of these are parathreads, but a parathread can be, that's why they are like the same code. A parathread can be upgraded or converted if they can pay for a full-time slot. A parathread can be converted in a full-time parachain. And also a parachain, if they don't see anymore the use case to continue spending that much, a lot of money, or just to be connected all the time to relay chain, they can be downwarded to a parathread. So they are just like on demand and full time, but basically the functionality is the same for parathreads and for parachains.
Okay, thanks.
Okay, there's one other question from the chat. So in his case, I have two separate data structures which need to be stored in the blockchain. So if I add everything to a single blockchain, I need to filter out DS, one DS every time I try to browse to the data. Is there a better way for this? Does that make sense?
Yeah, I'm not completely sure, to be honest, about that.
Yeah, no problem. Whoever asked that question, feel free to follow up in the Discord and we can work through it together. Sounds good. All right. We went a little bit over time, but yeah, I'll send the Discord link. Just hang around for a few extra seconds. Oh, Connor's got it. Okay, cool. Yeah, thanks again, Ricardo. I won't take up too much of your time this morning. Thank you again for coming in and sharing and answering questions.
Thanks to you for inviting.
Yeah. All right. Have a good one.